In this chapter, we will introduce for some of the network management functions, which including the Snmp, the Netflow, and also the REST API functions. First of all is the Snmp, which is the Simple Network Management Protocol. It's the application layer protocol for managing the devices on the IP network, which consists of four key components, including the NMS, which is the Network Management System, the Network Management Protocol. So this is the Snmp protocol that used for the network management, and also Snmp agent, and the MIP. MIP is the management information base that provided by each of the devices vendor. So the NMS, the management system, and the agents will communicate. So the system and the agent will communicate via this protocol, Snmp protocol, and also exchange the information using Snmp packets. The MIP is the database that used to manage the entities in the communication network. So most often it will be associated with the Snmp protocol. It contains the specific characteristics of the managed devices. So it contains the specific characteristics of the managed devices, on-premises object, variables. And Hillstone Snmp function will support the Snmp agent, okay, which the device is able to receive the request from the NMS and also respond the device information to the management system, and also Snmp server. So the Hillstone can also work as Snmp server to get the ERP information of the layer 3 switch or the device through the Snmp protocol, which will be used for the network behavior auditing for both of the IP and MAC address. When the device works as the Snmp agent, here will be the Snmp management structure. For the NMS system, it will send the Snmp protocol to get or set and trap the device information, and the device will respond through the Snmp agent by referencing the Hillstone MIP. Here is the Smp configuration example. As you can see, this is the NMS system which connected to the firewall through the Ethernet interface. The IP address of the NMS is 192.168.10.20, and the IP address of our firewall is 192.168.10.1. We can use this NMS, which is the PC, to manage the firewall through the Snmp v2c with this community string public. And in addition, the firewall device will be allowed to send the trap packets to the NMS with the community string private. And second example, the NMS, the PC, can manage the firewall through Snmp version 3 with some security level of the MD5 authentication and also the DS encryption. So the PC, which is the management server, can read the MIP2 and only has the right to modify the USM MIP. Besides that, the firewall device is allowed to send the trap packets. Here is the configuration for both Snmp v2c and Snmp v3. Let's have a look at the v2c first. So you need to enable the SNMP service on the device interface, And then you need to enable the SNMP agent function, and also configure for the engine ID. Also, you need to configure for the community and the access privilege, and also the community, public or private. So for the configuration through the web UI, the process is similar. So first of all, you need to enable the SNMP service at the dedicated interface that connect to the SNMP server or system. And then you need to enable the SNMP agent functions and set for the engine ID. After that, you can set the community and also the access privilege. So the permission is the access privilege. Okay. And you also need to set this, and also allow to sending the trap to the NMS, And here is the example for the SNMP v3. You need to add for some additional security features. Okay, so which you can see here. From here, you need to configure for some additional privilege and also the authentications or encryption algorithm, and also the user for the SNMP v3, the v3 user. So that is the additional configuration for the version 3. If working as SNMP server, so under layer 3 or the DHCP environment, the IP address cannot be used. To uniquely or identify the host. So it is necessary to identify the host through the IP and MAC address, and also audit the network behavior of the host. So in this case, we need to use the SNMP server functions to identify the MAC address of the IP. Here is the configuration. So first of all, you need to enable the SNMP service in the interface as well. And also you enable the agent function and config for the SNMP host. Okay, and also the engine ID and the community, and at the other firewall, which is work as a server. So this is work as an agent. Okay, this is the agent side. Another firewall worked as a server. So you need to configure the SNMP server. And this is the configuration for both Firewall 1 and Firewall 2 that worked as an agent, and this one as the server. And then after that, we are able to check the ARP table to see the IP and ARP and MAC address, IP and MAC address information. And the second one, which is widely used, for the system management, is the Netflow. So SNMP and Netflow actually offers two different approaches to the network monitoring. The SNMP lacks of the accuracy or deep visibility compared with the Netflow, which cannot do the deeper in traffic analysis. Therefore, we can use both methods for the network monitoring. So SNMP can use for fault management and also quick network performance overview. while the Netflow can use for accuracy, the accuracy in the estimation of the network traffic parameters. So which will be focused on the traffic analysis. So Netflow at the beginning was introduced by the Cisco. Okay, Cisco used the Netflow in their routers around 1996. In this case, to provide the ability to collect the IP network traffic. It records the source destination address and also the port numbers of the data packets in the network. Nowadays, Netflow is one of the important methods for the network traffic statistics and analysis. Netflow had been developed from version V1 until V9. So V1 is obsolete. So the commonly used version is the version 5 and the version 9. Because of the development of the IPv6, so currently the V9 version is the primary version to support IPv6. In our Houston NG firewall, we support the Netflow version 9. With this function, we can collect the user's ingress traffic, according to the Netflow profile, and then send this collected data to the Netflow server for data analysis. Here is one of the typical scenario for the Netflow. So our firewall deployed between the internet and the intranet, and also the user had the Netflow collector or Netflow analyzer that need to collect all this Netflow record from the firewall device. So the Netflow will only, as I mentioned, we will record the ingress traffic of the interface as you can see here. So we can enable the Netflow function in firewall and bound to both ingress and egress interface. So we will send the Netflow record to the Netflow collector or analyzer. And after the Netflow collector received the data, they will do the analysis based on the network traffic of the internal computer. So you can use this command to enable or disable the Netflow, disable the Netflow. And then the below parameter is used to configure for the Netflow profile. So you can use this as a reference to see the components of the Netflow profile. And here is the way how to configure the Netflow in Houston firewall to send the Netflow data. So first of all, you need to enable the Netflow functions under object. After you enable these functions, you need to reboot the device to take effect. And then you can create a Netflow profile. So this is the profile configuration, the name of this Netflow, and also the Netflow server IP and port. You need to add this Netflow server information here. And also the source interface, which is the interface that connected with your internal users. This is still source IP and together with the source IP. Okay. So we need to collect all this host information. And also you need to enable the Netflow functions in egress interface. That is the interface that connected to the Netflow analyzer or collector. So enable these functions in this interface that connected to the Netflow analyzer or collector. This is the configuration through the command line. So for the profile, you'd better to bind the profile into both ingress and egress, into both ingress and egress interface. And after that, you can check for the Netflow information from the source to the destination. So we, as I mentioned, we only record the ingress traffic. So only will show the single direction session. And you can also check the collected Netflow data at your Netflow analyzer or collector. So this one, we use the Netflow analyzer to collect all this Netflow data from the firewall. So this is the firewall IP. So this is the dashboard for the analyzer, and you are also able to see the detailed traffic that collected from the firewall. And another commonly used management tool, which is the REST API. So in the network or the network architecture, so the neighborhood interface of the component is the interface that conceptualized the lower level details, for example, the data or the functions that used by. So the component, a neighborhood, a northbound, okay, the northbound interface will used to interface with the higher level. So we have a northbound interface, so which is used to interface with the high level layer. So in architecture overview, so the northbound interface is normally joined at the top of the components. So the REST API, which is the simple way of sending and receiving the data. It's a simple way that sending of the and receiving the data between the client and the server. And it doesn't have any many standard defined. It doesn't have many standard defined. So when HTTP is in use, the operations available will be get, post, put, delete. So how to use the REST API in the firewall? So before accessing to the firewall system through the REST API from any third-party tool, so there is the process for identity authentication. So both the username and the password information need to be sent to the firewall device. So a token will be returned if the authentication passed. So this is we called X authentication token will be added to the HTTP header for the following API request connections. So the token comes with the time period. So the user needs to apply for a new one as long as the old one expired. So after successfully logging into the firewall system, the user can send the JSON message to the NBI via the REST API. And then it is able to perform the create or retrieve or update or delete operations to the firewall system, and also support to get other firewall data, such as the monitoring information, the alert, the log, and also the system information. Here is our REST API menu. So in our menu, we will provide the commands or the standard command for the logging, for homepage, for monitoring, for policing object networking system, and also other features. also other features. This is our structure for the REST API menu. So we will show the basic command and also the explanation for the parameters. So the user can follow this REST API menu to set the REST API connection between their REST API tool and also the Hailstone firewall. Here is some element description, just for your reference. In somehow we can use the tool Postman to test the REST API, So the password here will be a base 64 encryption format, not the plain text password. It will be using the base 64 encryption format. And if the login success, you will see the cookies for the device information and also the token information. So that is the REST API. So if customer, they have their REST API management platform, so they can easily manage through the REST API to the firewall. Okay.